Groovy. We are live. Hey, we haven't done this together for a minute. So let's just take a minute to let's just check in with like real life. So I ask that you please stop whatever you're doing for just a minute tops, I think. Just close your eyes and become aware of the bottom of your feet. You can do it, you can put them down or not, either way. But just really notice that sensation. And move your awareness to your big toe, as if you were going to wiggle it, but don't wiggle it. Here's a challenging one, for me at least. Can you feel the toe next to the big toe? I find that very challenging. What toe besides your big one is the most standout-ish? Which one just jumps to your attention? Can you move that awareness and just spread it out so that simultaneously your toes and the bottom of your feet are in your awareness? All right, give your toes a wiggle. Come on back. Mindfulness moment over. All right, well, I'm gonna stay sitting for a minute. So, friends, so did I mention exam 1 in my email? Yeah. I will check, you can't like make me think I didn't by not responding. So, I know. So, exam 1 will be next Monday. At the moment, the class ends, I think, or maybe it's up right now, I'm not sure. I created a review guide. But let's talk about what's going to be on exam 1. So now that probably induced some stress. I didn't want to talk about it before our foot meditation, our mental foot massage. Let me close this door. But you shouldn't stress about this, because what's going to be on exam 1 is basically everything that we've done so far that you've all kicked butt at. So truth tables. Does that sound stressful, making a truth table? No, that's straightforward, right? Logical equivalence. Do you know how to determine that? Truth tables, right? The truth tables look the same, they're logically equivalent. Done. See, you're already studying for the exam. There you go. The quantifiers, for all there exists. Sounds familiar, at least, right? Like, not like, oh, where's that coming from? I remember doing that. So all these things are in that homework 2, which is also a prep for the exam. So that homework is also a prep getting us ready for that exam. What else are we going to have to do? I'm going to ask you to prove something simple that's not something alien to you. So we're going to ask for a little proof. We're going to work on this today. I'm going to work with you individually and as a group to talk about this stuff. But you're going to prove if something is divisible by, or if n, that'll be it even, is divisible by some number, then some other expression is divisible by that number. Just like that. And that literally is the rhythm of those exercises that I gave you. And they're all flow. So this whole week is prep for the exam. So all our class, today we start prep for the exam. Wednesday, you come in here, prep for the exam. By the end of Wednesday, you should be able to like do the exam that day, I would think. That's my plan, to get you totally ready by the end of Wednesday. And you still got like till Monday to do that prep. That sounds like a bad idea. I can also create some extra problems like I did. So here's the other thing you have to do. So let's talk about exam 1, just real quick. I'll make a little bullet here. So truth table. And you don't have to write this down because it's all in the little announcement in World Class. So truth tables, logical equivalence, quantifiers.
Have you posted that announcement?
It should be up. Is it not up? I think I might have set it to open at 2, like foolishly, but it will be open.
Okay.
And maybe today I can, I'll actually get in there and fix that. Quantifiers, so that's the for all, and there exists, just the simplest things. If you look at that prep assignment that's up on Connect, that will show you the kind of questions I plan on asking you. Yeah, Joey?
Prep assignment. It's not
The
updated there.
homework 2.
No, I don't see homework 2 on Connect.
Yeah, I mean,
Only
It didn't-
Yeah,
Seriously?
just the 3.
only the
Son of a,
only the
oh,
4.
man, no wonder nobody started on it.
Yeah, I was gonna say.
Okay,
I thought you were-
okay, I guess I got a couple minutes. All right, yeah, well, we'll fix that.
Okay.
We'll fix that, but that's like the exam review, and it's not like a huge thing, so don't be stressed. And we will literally be spending, you can take today and Wednesday in class with me here, knock that shit out.
So that homework 2 is the exam prep?
Yes.
Okay.
So it counts as a homework and as a prep for the exam, so it's double duty, right? The homework aspect forces you to do it. You don't want to like get a 0, so like little impetus. So quantifiers, and then let's see, so then a little proof something exactly like this, and then a digital circuit. And so that's like where I give you a couple of inputs. Remember when we did the full adder, half adder stuff, and we had like the exclusive OR gates and stuff, and then the outputs and NOT gates and stuff like that. Roughly, you remember that picture? Yes.
Are the gates going to be labeled which one's which before the
They
exam?
are. Indeed, they are. Yeah. And by the time you actually do a couple of them, you'll probably remember. Yeah, but you haven't really done them yet. So attached to, there's an attachment to the announcement, which has a couple of problems, and I'll write up a solution set for you. But that's just one other thing to practice. And, oh, negating things, and just find the negative of something. So identify the negation of a logical statement. And let me tell you, here's kind of the keys here. De Morgan's rules are going to be key for that. De Morgan's laws. And let me refresh your memory on what those are, so you don't even have to go look them up. So not P and Q is the same thing as not P or not Q. And then not P or Q is equivalent to not P and not Q. So I give you a statement like, it is raining and it is cold. What is the negation of this? It is not raining or it is not cold. Just like that, right? You got the little rhythm just right there. So just simple. My exams are not intended to like blow you out of the water or like trick you, or like I'm gonna put a really hard problem they've never seen on there so they can spend the hour. No, it's like basic knowledge. I just want you to go through the process of memorizing it. So toward that end, since that's my goal, you get an 8.5 by 11 inch note sheet, double-sided. Anything you want on it? What would I put on it? Well, I would put an example of a proof. And you're gonna have at least 3 of those, because that assignment I'm gonna work on today, that is due at the start of class on Wednesday. I will have them back and available to you on Friday. You can come pick them up out of my box, or I'll scan it to you if you can't make that. But what I would have here are just like a truth table, you know? Like, how do I do a truth table? Put an example on there and put notes to yourself. Logical equivalence, what does that mean? How do the quantifiers work? So put examples. So examples with notes to self. How do I do this? You know how you learn best on there. I would have De Morgan's laws, right? De Morgan's laws. I would have an example proof, or two maybe, whatever you need. I would have a digital circuit example with notes. So all this stuff, the side is notes to yourself, like in your own language, what helps you remember what to do when. This doesn't sound too bad, right? No. And so it's, like I said, it's gonna be straightforward, nothing tricky, promise. And if I ever do something tricky, it's like a bonus question. Right? Like after you're done with everything, if you got some time, knock yourself out and enjoy this. I hope you enjoy it. My exams are intended to I would expect a lot of you will be done within 25 minutes. But, so that's what I write them for, so that it takes, on average, about 25 minutes, but you have 75. Right? So lots of time, no stress. You won't need a calculator, so I'm going to not allow calculators because you might have some kind of weird calculator I don't know about. There will be no computations needed.
We can't have a proof calculator?
You can't have your proof calculator, no.
Or a
You and
truth
that
table
damn proof
generator
calculator.
in
No. The truth table might, that I could see. But it sounds like more difficult to actually enter the truth table into the freaking calculator.
Could be a good way to learn it.
It's true. You can practice at home with it. That'd be great. It's a little study device. Any questions about any of this? No? Okay, so you have an assignment due at the start of the hour on Wednesday. It's those 3 proofs, only 2 of which actually you have to do because the other one can't be proved because it's not true.
Wednesday, it's the.
Oh, wait.
Well, you won't. It'll be a counter. You'll just say this is a false statement because, and let's talk about that. So has anybody started that? Yeah. Yes. How many else? Who else? 3. Just 3. Okay, 4. Yeah. Okay. You looked at it. Read the questions again. That's good. That's good shit. That's starting. So what I would actually like to do today is knock that out first, because that's something I want to collect from you on Wednesday, and I want to come around to everybody and see how you're writing and give you some tips on how to improve your narration, and stuff like that. So why don't we start there? Get that stuff out, take a look at it. If you haven't looked at it in a long time, maybe look at it now, gently and calmly. And did I post it in World Class or did I just hand it out?
Posted in World Class.
Oh, it's posted in World Class. Outstanding. Let me get that other announcement activated and that stupid freaking connect, so you can start on that too. God, I'm so sorry. But nobody ever, so for some reason, no one ever reminds me by email.
Well, I don't think we knew that there was gonna, this is
No?
the first time hearing of a prep.
Oh, okay, fair enough. It's a learning curve for me.
First one? Yeah. Oh, it's,
We can talk as a group about those proofs. I'm happy to do an example again,
The
if you need a
definition.
warm up.
this is definition, nitrogen, and it's good for 2K for some.
Yeah, so your first thing is getting those definitions. So let's talk about
Yeah.
those. Let's start working on
And it's
that.
even if, for some number, you can, yeah. Yeah. And even one is that you went over it. Yeah.
getting the connect going. Why is that segment not visible? We're supposed to open on the 7th, for God's sakes. Is the word chode? Is that a bad word?
Yeah.
Okay, I won't say it.
It's descriptive.
It is descriptive,
No.
because I was thinking to myself, you fucking chode. Sorry, that's offensive, I apologize. Why is this?
So yes, I am. Carlos doesn't have a joke.
Is it?
Carlos has a joke.
Okay, that's, okay. De-chode. Is it showing up yet? Could someone help me out and just let me know? Did it show up?
Oh, I
For the connect,
I
please.
see it.
Is it?
Yeah, I see it.
Beautiful, thank you. Okay, now I'll get world class announcement. Move to. Cool. So yeah, when I write the exam, I will look at those questions and model the exam wording and everything, like on what you see there. But let's focus on, unless you feel good about your proofs, then I'll come take a look at them. So let me ask this also, is that like having those proofs due at the start of class on Wednesday, is that too soon? We're gonna work on them today, but does anybody feel like anxiety about that? Be honest. No? Okay.
The proofs?
Yeah, the proofs. Especially if we work on them today, right? We should, okay, good. I don't, because I really don't want you to have anxiety. Not a good place to work from. All right, so here's us. It doesn't open till 2, so we'll fix that. That's easy. Now. Cool, all right, that announcement's not visible too. So, let me come around, see how the proof stuff's going. So, does anybody have anything written for the proofs yet that they'd like me to take a look at? Okay, so let me check out what you got.
Literally just, I think you gave us this definition.
Yeah.
So I just did the same thing in Animal 5.
Okay, let me take a look here, sorry, do you mind, let me get my different glasses, sorry, I need close-up glasses. There, that's much better.
I just copied the same thing you put.
That's great, that's the way to, that is the way. Yeah, beautiful, so what about this one?
I have no idea.
Well, so up here you've been using K. See, let's go through this because I want to make sure you understand. So it sounds like you're just kind of like good at getting the pattern right. But
Yeah.
it's not resonating meaning necessarily?
Not necessarily.
Okay. So let's all talk about this together, because I think you're not the only one. So this is good. So that first one, the first one is just a bunch of definitions, and let's talk about it, because you have to complete them all. So an integer n is divisible by 7 if there is some, wait, do I say, I think I used slightly different language. If n equals 7k for some integer k, is that the language I used? Tracy, was that kind of? Yeah, beautiful. So this isn't exactly one of the things, but what this is saying is that a number is divisible by 7 if it's just a multiple of 7. So for example, if n equals 7 times 3, n is divisible by 7. There the k equaled 3. If n equals 7 times negative 2011, that is divisible by 3 because it's 7 times something. It's a multiple of 7. So then a little later on, I say to you, and so what Tracy was doing was exactly what you should do. It's kind of taking my template like that, and when I say, what does it mean to be divisible by 9? Replace the 7 by 9. You got that, right? And that's good. That's pattern recognition. That's how you get shit done sometimes. But then I kind of threw a little tricky thing in there. So an integer n is divisible by k. Sorry, good Lord, sorry for the printing. COVID got my writing. By k if what? Can somebody help me out here? Just following the pattern. So look at the 7, but now I have a k in place of the 7. Is this good if n equals k times k for some, don't write this down, integer k? Can I just kind of blindly replace that 7 with the k?
You can't use k again, because those have to be the same value.
Exactly, so check this out. Here, and Tracy, this is kind of where we're at with yours, you want to look at the intent, not just the pattern. So the pattern helps, but understand the intent of what is being said. Right now, if I just roll like this is saying n is like a perfect square, right? And certainly it is divisible by k. It's a multiple of k, but it's not the most general thing. So I need to do what Cadence is suggesting and use a different letter than k here. So what I'm going to do is say n is equal to k times an m for some integer m. So now check this out. Now n is still a multiple of k. It is divisible by k. So if, we don't know what m is, but this number here is a multiple of k. Some multiple of k. I don't know which one. And I want to leave things as arbitrary as possible. Does that Does that make sense? Cool. So that's how you want to knock out that first part. A lot of it's just kind of like following the pattern, but then on this one we got to make a slight leap forward by using a different variable. Cool. So that's okay. Let's see. And then were you wanting me to look at it?
Oh, no, I was just
Okay.
gonna follow.
Okay.
along.
Great. Yin yang. Love it. You doing good? Are you still kind of working on it? Cool. Should we like go through a proof together again? Would that help to see? Yes, I've seen some nods. Okay, yeah, let's do that. Oh, sorry. Thanks. Let me check on what Yvonne's up to here. Okay, so this is all this stuff. Oh, here we go. Here's the. Okay, so this close. Oh, you're using I's. Oh, nice. I like that. It freaks me out because I think of, you know, the imaginary number, right?
okay.
So just as a mathematician, it's loaded, but it's beautiful. We do want to show that. Is there anything else there? It's beautiful. So, I love that. So so the word it, I would just say the integers, because it sounds kind of like it's referring to that. But the thing that's closed is the collection of all integers. Does that make sense, just language-wise? So this is good. So we're having this conversation at a subtle level that tells you we're on the right track, because we're just like tweaking tiny things for some integer I. So you know, n, and then you did this, because the integers are close under multiplication. So but what is the I here?
Just some integer. Okay.
But it's actually that k squared, right? So I would say here is an integer because, yes.
Down here, like I equals.
Oh,
okay, so
yeah, oh, you did it. Nice, that's beautiful.
Okay, so.
Great job.
Alright, cool.
Yeah, this is the tiniest little tweak on that language, and you've got the idea. Beautiful.
Alright, cool.
Nicely done. Kyle, how are you doing, friend? Yeah.
I'm just not entirely sure where to start.
Okay, so I think I kind of feel like that we need to. Are we good here, ladies? Are we feeling like, at least on this first part? Oh, I like that. Black background. Any of you feeling?
My issue is that I don't know what I can assume, and that I don't know how to does this show that this is proved?
Yeah, that needs more words for sure. So there's
Well, I
definitely.
don't think wrote.
Okay, gotcha. You're just kind of getting the
Yeah.
flow. Okay, gotcha. So let's see here. So I would avoid using the division. I would stick with that definition. Notice how that definition up there of divisibility is all about being a product of two things. And honestly, it just works out cleaner and makes it easier to narrate this whole thing if you do that. So let's talk about how to do that. Because you got the right ideas there, I see, but we want to change your attack.
So like making n equal to like 3k. So got it, that makes sense. I see what was why.
And that was probably snagging your mind,
Yeah.
right? Like that
Yeah.
division. Yeah.
It's rearranged. So the same thing almost.
Yeah, that should work to say like the whole numbers to integer.
So, yeah, he gave us that definition, so.
I started doing that on the second
Yeah,
and
same.
third
Yeah.
copies
Oh, yeah, that's
today.
right.
So if I did
apparently
n
when I was
over
working
5
on it a couple
equals
days
k,
ago,
that was still divisible.
I didn't
I
catch
think
that.
he's just
Oh,
searching
cool.
out division.
Yeah,
Yeah.
All right,
Yeah,
let's
but
Yeah,
do a
so
proof
that
of it.
should work.
yeah, that's okay. Conceptually, I don't understand.
Yeah.
Just didn't write it right.
Yeah.
Let's do this whole proof together. So I'll go through and then you stop me if you are unsure about what I'm doing, or you know, in any uncertainties you feel, vocalize them, please. So if n is divisible by 7, then n squared minus n, I'm gonna make mine harder than the ones I'll give you for sure, is divisible by 7. And yeah, okay, so we got to make sure, read that, and make sure you kind of understand what we're trying to show. So let's kind of go through what I want to show. So let's see, what is the first thing on that little sheet where I broke it down? It says assumptions. Yeah, got it. So assumptions. This is kind of like all part of scratch work. Assumption. We're assuming n is divisible by 7, and we just wrote what that meant. In fact, it's still up over there, right? So n is divisible by 7, so n equals 7 times some other integer. And you don't have to use k, let's not use k to emphasize, that's my L right there. So n equals 7 times L for some integer L. Right, so I'm just taking what my hypothesis and writing it as a formula, and that gets me a hook. Having that formula gets me a hook, because I want computations in the end. I want to just do some simple math to show this. n is divisible by 7, so your proof will start like that. Just won't have 7 there necessarily. Any questions on the assumption? Okay, and then what's the next thing, sorry?
Want to show.
Want to show. Want to show. WTS. Want to show that n squared minus n is divisible by 7. And so then I translate that for myself to a formula. And that's my link. I'm kind of almost moving backwards. This is the last thing I want to say. I'm kind of like working my way up this way. This is working me down this way, and hopefully I can meet in the middle. So, and this is divisible by 7, i.e. n squared minus n is a multiple of 7. Now I don't want to use L because I used it up there. So it's equal to 7 times m. You pick your favorite integer. Yvonne was using I. That's cool too. Whatever letter, there's a lot, there's at least 26 things to choose from, right? Or 25 after you pick your n. So, for some integer m. Yeah? Does this make sense that this is what I want to show? Let me know if not. That's what we're here for. Okay, so, and then what's the next one? Scratch?
Yeah.
Thank you, thank you. So scratch. So I start with my hypothesis. Here's where I'm starting. So scratches start here. So I'm starting with that. I assumed that. So n squared minus n. Then I go to the thing I want to show is divisible by that number. And I work out what does that mean? And I do a substitution. So substitute the thing that I labeled up here. So notice how I'm using parentheses to be safe. Looking good? Yeah. Simplify, do the work. So this is equal to 7 squared L squared minus 7L, which is, now what is it I want to do? I want to show that this thing here is 7 times something. If I can show that this is 7 times something, then I'm done. Can you see that it's 7 times something? What is it 7 times? So what do I put in here so that this whole thing is actually equal to that? Goes in there.
Is it 7L minus L?
7L squared minus L, beautiful. But don't forget the squares. But yes, exactly, yeah. So look, just factored out a 7, that's all I did. That's really it. Is this okay? Do we need to talk at all here about this? Okay, they're all gonna go the same, and that's why I have a bunch there for you to do. And there's some in the connect as well. So why is this an integer? Why is this some integer? I know Yvonne knows. Yes.
Because integers are closed with multiplication and addition.
And subtraction, sure, yeah, good. So integers, if I multiply 2 integers together, I get an integer. You multiply 2 whole things together, it's a whole thing. You subtract 2 whole things, they're still whole. So because the integers are closed under multiplication and subtraction, multiplication, whatever, you know what I mean, and subtraction. That's it. So now, if I were to let this thing, so this equals 7 times m, that's what I wanted, where m is this dude, or individual, no gender. That thing right there is equal to m. So let me stop. Please, please, please tell me if this makes sense. At least you can follow the flow. And this is like your template here for how to do these things. So that now I write out a formal proof, and all that means is I put pretty words around it and use whole sentences. And I'm gonna give you a couple shortcuts here with some cool notation if you want to use them. So then my final proof is to put this together. So watch this. You can just totally take my language and just mimic it. That's how everybody learns to do stuff, by mimicking, right? And then once you're good at it, you can get crazy and creative. So, since n is divisible by 7, n is equal to 7, what did I say up there, L, for, now check this out, here's a fancy way to say for an integer L. It's a fancy math way, you don't have to, if you're already like, I don't know, this is enough, I don't wanna do that. But this just means L is in the integers. So it's beautiful, math notation. This means element of, or just in, is in. And this symbol right here is Z, a fancy Gothic Z, stands for Zahlen, the German word for integers. So this just means right here, L is in the integers. But it's faster than writing that, right? It's just nice and quick, it's like compact, fast. First L in Z, period. Got a nice full sentence, got a verb, nouns, subject, all sorts of stuff, period, capital, holy shit. That means, now I have to write the consequence headed toward my ultimate goal, that n squared minus n is equal to, here's where I substitute. You will always be substituting at this point. So that's 7L squared minus 7L. And then I do some work, which is equal to, and you could, maybe here you did this. That's okay. But now is where I start to head back to where I want to show, which is this. This is what got me the multiple of. So that is equal to 7 times 7L squared minus L. Equals 7M, where M equals this thing. And M is an integer. I use my fancy new notation because Z, the integers, is closed under multiplication and subtraction. Times and subtract. Thus, and here's the thing we just did right. Thus, or so, or hence, or pick your favorite. Here's nice concluding words, nice math words for transitions. Thus, hence. That's like 1800s. We don't want to use a whence. How about therefore, or so that. These are nice transitions. You can use any of those. Thus, n squared minus n is divisible by 7. Because it's a multiple of 7. That's it. That's the end of the proof. Every proof you write is going to look just like that, at least for a while. After the exam, we're going to talk about some other kind of proofs. But up till the exam, that's your proof. You put in the blanks. So now, my friends, if you haven't done the first one on that page, please try it, and then I will come look at what you got going on there and give you some pointers. If you feel good about that whole page, let's see, one of those is not provable. Which one? The second one? Yeah. So the second one you can't prove. You just got to come up with a value for n that makes it untrue. We'll talk about that in a minute. Let's knock this out first. And I will consult with anyone who has other questions.
So just work on the first one right now.
Sure, yeah. Yeah, work on the first one for now.
What's the definition for prime number? Because this is
Ooh.
what I
Oh, gotcha. Okay, that's a great one, Yvonne. So for number 2, that's, yeah. In number 2, I talk about prime numbers. And a prime number. So prime number is only divisible by 1 in itself. So only divisible by 1 and itself. So in other words, and we started 2, so here's the prime numbers, 2, 3, not, here, let's do this thing called the Sieve of Eratosthenes. So you go through and you say, is this number divisible by anything besides 1 in itself? 2 is good, 2 is prime, 3 is prime, is 4 prime? No. Nope, divisible by 2. 5?
Yes.
Good, 6?
No.
No. 8? So like, what's a good rule? Are even numbers ever prime? No, what are they divisible by? 2. So even numbers are divisible by 2. So all the evens are out. What about 9? 3. Would anything that's a multiple of 3 be x'd out? Anything that's divisible by 3 is x'd out. That. We already got 12 because of 2. That's out because it's 3 times 5. 18, next one, I would x that out. So far, here's my primes. And that was 17. What about 19? Is that prime?
Yeah.
Sure is. 18, sorry. Okay, forgot how to count. X that out. Is 20 prime? It's even, can't be prime. Yeah, 21? No. Is 51 prime?
Yeah.
What? So you know how to tell if a number is divisible by 3? Add up the digits. If that's divisible by 3, then the number is.
Wow, that's a nice little.
Isn't that a nice little
How does
rule?
that work?
Wow.
I'll write up a proof.
Well, wasn't there a proof in the reading that might have something to do with that?
Oh, maybe.
I forget. I could have just
Maybe.
read
That would have been a
somewhere
pretty
else, 'cause
intense proof, so.
I just heard that recently. I was like,
Yeah.
how does that work?
51, add 5 plus 1, it's 6.
So that ain't divisible by 3. And in fact, it's equal to, this is my favorite multiple of 3. Because it's 3 times 17, it's like, what? Who would have thought that, but it sure is. That's a sweet number. Yeah, it really blows your mind. Yeah, right? So yeah, you are divisible by 2 if your last digit is even. You're divisible by 3 if, well actually, if your last digits are, well, I don't want to say that. If your sum adds up to a multiple of 3. Divisibility by 7 is pretty weird. I don't want to get there, but there's some ways to do that. What about 5? When are you divisible by 5?
Whenever it ends in 5 or 0, basically.
Perfect, 5 or 0, yep. I mean, just think about the multiples of 5, right? They alternate between 5s and 0s at the end. Yeah, perfect. And then it gets on and on and on, but we're not worried about that. Divisibility is a big deal for computer scientists. You will often be checking, you're in some for loop. You're in some for k equals 1 to n, and you want to maybe have something happen every multiple of 3, every multiple of 5. So you check for divisibility as you roll through. You do certain things at certain times. So this is not just bullshit. We're not doing it just for, grins and other things. All right, sorry, I'm getting off and way off topic. So get that first, anybody, let me know when you have that first proof you want me to look at it, or anything else you want me to look at. Who had asked about prime, Yvonne? Was that you? Did that help?
Kinda.
Can I remember, refresh my memory what the question even was?
Yeah.
Yeah, let's actually, I'm gonna talk about that in just a minute, but if So can you think of a prime, can you think of a value for n that's prime, but twice that number is divisible by 5? Does that make sense?
Yeah.
Yeah. So can you think of a prime who twice that prime is divisible by 5? And if you can think of that,
And it's
It was mean. That was mean.
is it? Yeah. Okay. Well, it's not on a test. That's okay. I reserve the right to be a total bastard outside of tests.
No, I mean, it was good. It was
Good.
just like,
Awesome. It's tricky. The wording is
Nice, solid.
alright. Yes,
answer your question about this one.
absolutely.
So, following this proof, then, would just be n squared
It's so good.
equals like
It's so good
9,
though.
so then
I
n
think I saw
squared.
this like yesterday and I was like, that's hilarious.
It's
Love
good.
the first step.
So no, you're going a little too fast. So what did you let n be? So what is n in this proof? 3a. So now, so n squared. So go n squared equals, put a parenthesis, 3a, which is what n is, close parenthesis, squared. Then simplify.
So we don't need this really at all.
Excuse me. No, it's kind of like that's where we want to go.
So just find n first and then figure out from there. Okay.
Exactly. Yeah.
Do we need any other assumptions or like what else are we wanting to show?
No.
Okay.
Because the only assumption we have is that n's an integer and it's divisible by 3. You've already like
Okay.
totally used those all.
Cool.
Does this make sense?
Yeah.
Do you see why that's a little easier and
Mhm.
better handle?
Yeah, absolutely.
Okay,
The
awesome.
division, yeah.
Yeah.
Thank you.
You're so welcome. Anyone else going? Okay, let's talk. That's great. It's not great that you're confused, but let's talk and clear it up. So, n is divisible by oh wait, so that's not our assumption, so you're jumping to the end. So see this if, then, so the assumption is the if part, whatever the if part is. So this should be n is divisible by 3. So let's go back, let's do this.
Is that a rare Pokemon? No, that's my favorite. I'll give this one.
Perfect, so then, what does that mean? We go to that definition, what does it mean that n is divisible by 3? So now we say, so n equals what? What does it mean to be divisible by 3? Yeah, there you go, solid, yeah. It's 3 times something else. Awesome. We know k is, just make a little note, k is the integer. Maybe a little space there, just so it's not looking like part of that, yeah.
I think this needs to be worked on.
What proofs?
In your room.
Right, yes, there you go, you're gonna use that. Awesome, that's beautiful. Okay, so that's our assumption. Awesome. Now what we want to show is that n squared is divisible by 9. So let's write that now down in the want to show. So the want to show always comes after the plan. Bless you.
Thank you.
So what does that mean? So let's kind of keep it away from that. So let's not think about that. If I just said, hey, I've got n squared is divisible by 9, what does that mean? So let's write out n squared. So n squared, comma, so n squared is equal to what? And we put an equal there, sorry. Equals. What does it mean to be divisible by 9? Yeah, and let's just use a letter different than k, because we don't know that it's the same k, so pick your favorite letter. There you go. So we want to show n squared is divisible by 9 means n squared equals 9 times something. Does that make sense? Okay, so now, let's go down to the scratch work. So, scratch work always starts at the assumption. So let's copy that assumption. So, just the part n equals 3k, because we're just gonna do a little computation now for the scratch work. interested in is n squared. So if n is 3k, what's n squared equal to? Let's put it underneath maybe. Yeah, exactly. That's right. And then to the left of that, put n squared equals. So we keep track, we're remembering what we were doing and why. Okay, awesome, good job. So, can you simplify that a little bit? What is 3k times 3k? How can you simplify that? Not exactly 3k. Well, the whole thing, yeah, 3k quantity squared, but if I like said, just write that. So you multiply them together, you can move the 3's together, right? So do you see 9k squared? You see what that's what I'm looking, you might not know what I'm looking for, because I know you do. Because I've seen you doing calculus, so I know you know that. Okay, so, cool. And then, let's hit return. Yeah. So what I want to show is that n squared is actually 9 times some integer. Now check it out, we know 9 squared, or n squared is 9 times k squared. Is k squared an integer? Why? I agree. Why? What's that phrase we always talk about? The integers are closed under. Yes, ma'am, solid. So, and here, but actually to the right of that, let's just do this. So you have this in your notes and you see it, so equals 9 times an integer. Just write the word integer. Because, and let's write this whole sentence out, because k squared is an integer. Because the integers are closed under multiplication. Does that make sense? Yeah, you see? And so then I can just say underneath here, so, write the word so, and I'll keep these words above final argument here. Yeah, so, n squared equals 9 times m, let's use a different one. What's another letter? Oh, 9m, yeah, 9 times m, where m equals k squared. So n squared is a multiple of 9, i.e. n squared is divisible by 9. And I think writing this stuff out would be good, so that when you read it back, it's kind of reinforcing. N squared is divisible by 9. Perfect. That's it. Do you kind of see? Yeah, so now your final proof would just be basically just cutting and pasting what you've done here and just cleaning it up, and you don't have to put all the like words in between, but you've pretty much got a proof right there. Feel better? Okay, awesome. Well, you are so welcome. How are you doing? What?
Copy and paste it.
Okay, cool, but are you
But,
understanding?
Yeah.
Yeah?
Yes. Yeah.
And you would tell me the truth, Sophia.
I do. I lost where the N came from, but then I found it.
And you figured, so you came back, you got it under control?
Yeah.
Beautiful.
Yeah.
Okay.
And I lost a little bit.
Okay.
Go back.
You let me know if you get lost again, okay? Please do. Kyle, my friend, how's it going for you? Is this making some sense, or?
Yeah, just up
Awesome.
until this part, I'm not entirely sure where to go from here.
Oh, okay. Well, we're kind of just gonna simplify this thing, because, so, actually, let's come back up here to this line real quick. What does it mean to say n squared is divisible by 9? So maybe put comma IE or something, just as a reminder. Yeah, so good, man. Yeah, exactly. So really all I want, do you see? Yeah. That's great. Use a different than k. So if we're gonna use k in one spot, let's use, so that we don't get confused and think they have to be the same number. Yeah, beautiful. And instead of for n, you put not true for just any. There's like one. Okay, beautiful. So now look at what we got. So this was your assumption. N is divisible by 3, so it's 3L. So N squared is 3L squared. And then you start writing this out. Now, can you see how to move from 3L times 3L to 9 times something?
Just instead of parentheses, and it's basically just the times that you just multiply them up together, but I was just confused because we just
Oh, I see what you're saying. But so what's 3 times 3 though?
9.
So equals 9. And then what else then? Times L squared. Awesome. Look what you did. So now you showed that N squared equals 9 times L squared. So it's 9 times an integer.
Right.
And you're done. You just have to say that. See, do you see? Yeah, you were right there. You were like right on the cusp.
Yeah, those are more, yeah, I just got a little confused because I thought that was just add numbers like one. That's why it is so it's.
Got it. Yeah, I see what you're saying. There you go. That'll make it a little easier. So do you see?
Yeah, okay.
Yeah.
Yeah.
You got it. Okay, awesome.
Thank you.
Yvonne, did you get that one?
Kinda.
Kinda? Would you come up? What
I
was
mean,
your?
I still don't know like the mathematical definition for prime number.
Oh, well, okay, so I'll tell you, so
Jordan,
n is
was the
prime,
last time we used
i.e.
the
n
switch
is
statement?
divisible only by 1 and itself.
In the unit of switch states.
But you can't, so you won't be able, don't try to use the definition here. So
Okay.
I'm gonna go up here, let me make a round, but I gotta talk to everybody about that one.
Okay.
But there's no proof required,
Oh, okay.
because that's why you're hurting, that's why
Yeah.
things are painful, that's why it's suffering is happening. This is looking
I'm
good,
running out of
Joe.
pencil, Dr. T.
What's that?
I'm out of pencil, man. Oh, thank you, sir.
Nice guy.
I think I got this
I
part.
think this is
that's
really
that.
good.
And then I need to do, that means n squared equals.
Not good.
But then I'm lost, I think.
Yeah, so things are getting a little confused out here in this part, yeah. So, this, we're good, we have this pencil, thank you, Abraham. Saving the day, man. Once again, saving the day. So, since n is divisible by 3, that's this, right? So this is n divisible by 3. So I'm gonna write that here because n is divisible by 3, just like so when you look back at it. So here we go, since n is divisible by 3, then you jump to like a squared or something there. That's too fast.
Okay.
You gotta like hit the throttle, the brakes here. Since n is divisible by 3, n is 3L for some L. Yeah? Okay.
Okay.
So now I'm just like saying,
Using that stuff.
yeah, exactly. It's like, what does it mean to be divisible by 3? It means that. Cool. So then that means, okay, I like it. And L is, oh, beautiful. We got this. L is an integer. Solid. So what is now n squared equal to if that's, so now I got things in concrete.
Does that mean that n squared would be that one?
Yes.
So I can just copy paste.
Solid, and then do your simplification. This is all beautiful. I love it.
And then I just simplify from there on this.
Yeah, this is it. I basically copy all this down. And then at the end, you just have to say y is 3L squared an integer. After you get down to the bottom.
Right here.
Yeah, that very last page. So go ahead and let's get you there first. So now you can say equals 3m, or wait, oh, sorry, was this one supposed to be divisible by 9? Sorry, oh yeah, this is.
It is the 3 and the 9.
Okay, so we
This is the one
actually.
that doesn't get proved, right?
Yeah, so actually erase that. So now, we've got 3 squared times L squared. Do you see a 9 in there?
3 squared.
There you go, so right equals 9.
So just.
Yeah, anywhere equals 9L squared. So, you've basically shown now that n squared is 9 times L squared. Why is L squared an integer? That's the like kind of the crux of things. Why is L squared an integer? So what is L? L is an integer. Right? So L is an integer. What happens happens when you take an integer and multiply it by another integer? A whole thing times a whole thing.
You get another whole
I
thing.
get another whole thing. So then we could put here, this equals 9m, so on the next line, that's right, equals 9m, where m equals L squared. And now I say, and m is an integer because why? What's the fancy?
Because an integer, for it to be squared has to be an integer.
Exactly, so I say because the integers are closed under multiplication.
Because they're closed under multiplication.
That just means when you multiply two things, you get the same thing back.
Okay, so you're basically just saying, a fancy way of saying that L squared has to be
an integer.
because it's L squared.
Correct, because the integers are closed under multiplication.
Okay.
It's an E there instead of an I. It should be an R, the word R, A-R-E, as opposed to is, because it's a plural, they're like, it's a bunch of stuffs, yeah. The integers are closed, there you go.
Closed under multiplication.
Yes, sir, absolutely.
Okay.
So, and now
This
you
was the
just
hardest
almost done,
part, right?
exactly. So now you just say, so, you just showed n squared is 9 times m, so n squared is divisible by 9. That's literally the definition of being divisible by
Okay.
9, you're 9 times some integer.
So then I can just do the thus.
Yeah, thus, yeah, you can thus, hence, you can get fancy if you want,
Wait,
therefore.
So then I'm gonna say thus, and is divisible by three or by nine. Okay.
N squared is divisible by 9. Because that was what we wanted to show.
Oh, yeah, thus.
Want to show, so you can always check back on your want to show. That's a beautiful proof. That's it.
Alright.
Solid, cool. Does that make some sense, kind of coming
Yeah,
together?
this part's a little bit more complicated.
It
This
is.
part, I understand.
Okay, good. Yeah, but you got another one in there you can practice, and there's definitely some in the Connect to kind of practice this thinking.
Okay, so n isn't divisible by three, but n squared is divisible by nine, that's what the
Yep.
on this one is.
Yep.
Okay.
So n is divisible by 3, but n squared is divisible by 9. Yes. Okay, are you good for now?
Yeah.
Okay, cool. Yeah, Yvonne, absolutely.
I don't know.
Okay. Boy, you can get this, just right on the left. So this, and this prime. So this, the problem with that is that's not an integer.
Okay.
Let me go up and address this one. Let me show you. Hold on, and then I'll be right. Abraham, I'm sorry, I'll be right there, sir. Let me talk about that second problem.
First big one. Number two. Well, I'm on number three now.
So let's see. Yvonne, could you please read me what are we supposed to prove for the second one?
For all integers n, if n is a prime number, then 2n is not divisible by 5.
Okay. Is prime. And 5n is
2n.
2n, thank you. 2n is not divisible by 5. So this will be in the recording if you don't have the brain space to think about this right now. But when I get a statement like this, sometimes I just like to look at cases and see. So I'm going to look at the relationship between n and 2n when n is a prime number and see if I believe this thing. So when n is prime, so I'll start listing. 1 is not, we don't start the primes at 1, we start at 2, 7, 11, 13. Let's see what happens there. Then 2n is going to be 4, 6, 10, 2226. So I'm looking at the statement, it's claiming if n is prime, like all these are, then 2n is not divisible by 5. So 2n not divisible by 5 means 2n is not a multiple of 5. Just another way to say it. Sometimes it's an easier way to think of it. Is that true? So this isn't a multiple of 5. Check. Not a multiple of 5. Is this a multiple of 5? Yes. So this right here just bars the whole thing. So this here, 2n is a multiple of 5. So that statement's a lie.
And that's all you need to do.
And that's it. So now I just say this is false. So this is false because, so yeah, there's no proof for this one. And if poor Yvonne, I wanted to stop this too soon, but Yvonne has been trying to like prove this statement or disprove it with like proof techniques. To disprove something, you just need one example where it's false. So this is false because if n equals 5, 2n equals 10, which is divisible by 5. I'm not going to put something like this on the exam, by the way, because I feel like the language is a little tricky, and it's kind of like you thought it was tricky. And
Yeah, I mean, when you wrote it out like that, it seems easy to find, but like, when you're looking at it, like, well, 5 when you shouldn't have to worry about that, so I was like going through like 3, 7, oh, works with 11, and
yeah, yeah.
I had a whole proof wrote out for it being true, so.
Oh wow. I'm glad we talked. All right, let me keep talking to Abraham.
Let's do something like that.
How are you feeling here about this?
That n is prime.
Oh.
Like when it gets to like scratch words.
And that 2n is not divisible by 5.
Okay, so let me kind of give you some tips on this. So you're going to start, the tricky part is getting the handle. And so the handle is getting this, oh, you're using, I wouldn't use n here. So hold on, let's see. So n is divisible by 3. So n equals 3 times some. You're using n in both places, and it might not be true. What if n is 6? Then 6 equals 3 times 2. See that n there says it's the same number. And the only number that's 3 times itself is 0.
Oh, so I would use a different.
Use a different letter. So let's change that together right now. So let's change that. And that's not helping your mind here for sure. You know, it's making it really. Is that an L or an I?
Yeah.
Okay, awesome. So for some integer L, change it to L. Cool. So first step is when you got this, use different letters. Okay, we want to show that, oh my gosh, that whole thing became an exponent somehow.
Yeah, I should take that out, but I couldn't.
Yeah, here, I'll show you how. Want me to show you how?
Yeah.
Okay, so then you go to font. Shit, where's the, how do you right click? Can you right? Thank you so much. Okay, well, it's still the same damn thing. Font, go to font. So it says superscript, take that off. Watch this, you're gonna like it. So let's start like this too. We got this guy here. Oh, I think it was just like a remnant from, why is that? Because I'm hitting the enter. Thank you,
Yeah, no,
thank
you
you
can
so
take me
much.
too.
Thank you, sir. Yeah. So we want to show that n squared is divisible by 9. So can you change that 3 to a 9? And let's write this out together so when you look back at it, it's in your language. So in other words, I want to show that n squared is 9 times some integer, or 9 times something else. Does that make sense? To be divisible by 9 means you're 9 times something.
Okay.
So like, what are the numbers that are divisible by 9? They're just multiples of 9. 9, 18, 27, 36, you know, it goes on and on. So I want to show that n squared is one of those numbers. I don't know which one, but it's 9 times something. So let's write out next words, if that makes sense to you. In other words, we want to show that n squared. Yeah, it's just put, oh, here, I'll show you the cheesy way. Let's do it the computer science way, because you're gonna be doing this anyway. Use the caret, the shift 6. So hit shift 6. There you go, 2. There you go. That's computer science way. Perfect. And it's easier than all that crap. N squared is a equals 9. Let's back up to the is. Equals 9 times. And then let's write just the word some integer. Write those words, some integer. Okay, so let's stop for a second. Read that and make sure that's making sense to you. Okay.
That n squared equals 9 times some integer.
Yeah, we want to show that n squared is divisible by 9. In other words, n squared is 9 times 2, or 9 times 7, or 9 times something.
So it would have to be equal to, well, like either 18, 27, 36.
One of those things, or it could be a negative too, right? It could be negative 9. We don't know. So that's why we say some integer, because we don't know what it's going to be. We don't even know what n is. It's just any, it could be any integer. So let's go down, hit return, and then put IE, and then n squared equals 9 times m. There you go. And then for some integer m.
So that just means for like any.
Yeah. So then write the words for some integer in. Write that sentence.
Okay, so I'll just be like any possible.
Yes, sir. So then, so this is what we want to show. If we can show that n squared is equal to 9 times something, we're done. So we're kind of like setting a goal post right there. Okay. So now, yeah, we should believe it. Yeah, beautiful. So now we'll come down to scratch work. What was our n? It's not 3n anymore. What is it actually? 3l. Perfect. Cool. So hit return. So now what's n squared? So square both sides of that. So n squared. Yeah. It's okay. It's capital. Don't worry about it. We know it's not. So almost. Okay. Yeah. And then maybe put in left parenthesis 3l. Close parenthesis squared. So see right now I'm just squaring both sides.
Yeah.
Squared is that? Okay. So equals. Simplify this. What is 3l squared? Can I simplify that too, or expand that?
I feel like last year was still pretty good.
Yeah.
If you get into your lunch,
There you go. See the 9's popping out.
Yeah.
Times what?
Yeah.
But L squared right here.
I like the numbers.
Then we're gonna let it be. We're gonna call it M in a minute.
I'll be,
but
would that be
9L squared. Because we still have this square.
Okay.
Yeah. So right.
They
So
charge
L
you
squared.
before you get it, so they can just make it as crappy as they
Perfect.
want. And
Okay.
people are
Then we'll have another.
That's true.
Yeah, and that equals 9M.
I don't care. I want a bunch of that. I want a bunch of good.
Where, now we write sense, where M equals L squared.
It's all four.
We're just kind of substituting, we're just saying, right?
Sure, no, it's kind of facts.
So now why is that an integer? Why is M an integer? That's it, once we say that, we're done. Because it's L squared is just, it's an integer squared, so it's an integer. So you say, where L is an integer.
I have to run quick.
Yeah, no, please, go, let's go.
Thank you, good
Integers
check.
are closed under multiplication.
Thank you.
Oh, gosh, okay, we'll talk on Wednesday.
Okay.
And we'll get them at the end of the hour on Wednesday, okay? Don't stress.
Thank you.
Thank
Have a
you.
good day.
Thank you, you too.
Okay, yeah, like not even to know, like.
Thank you, Professor.
Thank you.
That was like, distributed.
Yeah. This is making sense.
Yeah, it does make sense.
Thank Oh, hey, Joey.
Yeah.
Oh, Were you actually interested in like working for ITS?
Yeah, if that's possible, I definitely would.
Okay, just wanted to
Yeah.
double check on that.
Okay.
I'll talk to some people, okay?
Okay, that'd be great, thank you.
So now underneath this will make new sense, because we got a lot going on in that sentence. So, n squared is a multiple of 9. In other words, let's write this down. N squared is divisible by 9. Yeah.
Okay, I think I'm getting that.
Yeah?
Yeah, because like way up and like it got kind of easier when like I started going from like that.
Uh-huh.
It's like 9, 18, 27.
Yeah.
And then you know that 9 would go into any of those numbers
Yes.
depending on n.
Yes.
Okay. I think that's
Coming together, feel a little better?
Yeah, as long as I have an example to go back to.
Okay.
I think we can go on.
Okay, solid.
And then so this is for the scratch work.
That's scratch. So put that together, like, see that final proof there?
Yeah.
Maybe take a picture of it and then kind of mimic that language in the flow. It'll be on the recording if you want, of
Okay.
course, you know, which I'm gonna shut down now.